Hello everyone, I'm Rilo, and in this module, we'll be discussing orthogonal projection. Let's dive in. By the end of this course, students are expected to have these abilities. Determine the orthogonal projection of a vector and its norm. The definition. So we have a vector u. It can be expressed as the sum of two vectors, a scalar multiple of a non-zero vector a, which we call this w1, and a vector orthogonal to a, we call this w2. And the figure below illustrates the possible case of the composition. So we have in figure A, the vector u can be decomposed as w1, which is the scalar multiple because they are collinear to each other, and w2, which is perpendicular to a. With the figure B and C also similar. A vector w1 is called the orthogonal projections of u on a, or the vector component of u along a. And vector w2 is called the vector component of u orthogonal to a. And the orthogonal projection of u on a, we can calculate, we can determine the vector, and also we can determine the w2 also. For the orthogonal projection of u on a is formulated by projection u on a equals to u dot a divided by the norm of a squared times vector a, where the vector component of u orthogonal to a is determined by u minus projection of u along a equals to u minus u dot a divided by the norm of a squared times vector a. For example, we have u equals to vector 2 minus 1, 3, and a equals to 4 minus 1, 2. Find the vector component of u along a, or we can say orthogonal projection of u on a, and the vector components of u orthogonal to a. The first step is we calculate u dot a and the length of a squared. U dot a is calculated as 2 times 4 plus minus 1 times minus 1 plus 3 times 2 equals to 15. And the length of a squared equals to 4 squared plus minus 1 squared plus 2 squared equals to 21. Thus, the vector components of u along a, or orthogonal projection of u on a, is the orthogonal projection of u on a equals to u dot a divided by the length of a squared times vector a, or 15 divided by 21 times vector 4 minus 1, 2, or equals to 27th minus 5/7, and then 10/7. And the vector components of u orthogonal to a is u minus the orthogonal projection of u on a, or equals to 2 minus 1, 3 minus the orthogonal projection is 27th minus 5/7 and 10/7 equal to minus 6/7 minus 2/7 and 11/7. So the conclusion of the module is the first one is the vector u can be expressed as the sum of two vectors, the scalar multiple of a, non-zero vector a. We call this orthogonal projection of u on a, and a vector orthogonal to a. And we call this the vector component of u orthogonal to a. And the orthogonal projection of u on a, we can calculate it by the formula projection u on a equals to u dot a divided by the length of a squared times vector a. And the vector component of u orthogonal to a is determined by u minus the orthogonal projection of u on a, or u minus u dot a divided by the length of a squared times vector a. Alright everyone, that wraps up our discussion on orthogonal projection. Thank you and see you in the next video.